So this was about central limit theorem. So basically central limit theorem is applicable in basically two cases. Can someone tell me what are the two cases? In which two cases the central limit theorem is applicable? या मैं बोलूँ आकर्षण बोलोगे?
No, sir.
Okay, Tanvir?
So when you remove samples का means,
No.
the mean.
And the point is which case? Good, Atharva. In which cases the central limit theorem? I'm not asking ki what is the central limit theorem. So in which cases the central limit theorem is applicable?
वो याद नहीं है.
Yeah, Atharva. You got it right. Good. I'm happy, Atharva. Go on.
Sir, either n is should be more than 30 or it should
30
be
or more than
normal.
30. 30 or more than 30. Not more than 30. 30 or more
Okay.
than 30. That is
So the parametric tests, like
No. I'm just saying central limit theorem is applicable in one of the two cases. One is sample size should be large, that is 30 or more than 30. And second one, Atharva,
Or it should be normally distributed.
population should be either normally distributed or the sample size should be large. So let me just put it on the screen. The central limit theorem is applicable if one of the two conditions gets satisfied, when the population is normal and when the sample size is large. And these were the same conditions that we had seen in the hypothesis testing. The hypothesis testing is valid when one of these two conditions are going to get true. So be it central limit theorem or be it hypothesis testing, one of these two conditions required to be satisfied to do central limit theorem and to do hypothesis testing. Yeah, Kashin was saying something.
so these are the parametric tests only, no?
हाँ, parametric test, that is hypothesis testing and central limit theorem. To
Okay.
apply either of these two conditions, not both of this, both भी
हाँ.
चलेगा, लेकिन at least one condition, either population should be normally distributed,
Or
that
sample size should be 30 or more than
more than
30.
30. That is skewness should be 0 or kurtosis should be
Or
3,
should be 3. Yeah.
and the
Okay.
sample size should be 30 or more than 30.
Got it.
Then what were the things? Number one thing over here was basically that, एक second, बंद करता हूँ. The thing over here was that basically the average of all the sample means. For each sample, you calculate the mean. So you have for each sample 1 ka sample 1 mean, sample 2 mean, sample 3 mean. Average of all this means is equal to population mean. So that was the conclusion number 1. And second, for each ये जो samples हमने जो किए थे sample means calculate किए थे उस सारे sample mean का जो standard deviation है, so basically for the sample 1 you calculated its mean, for sample 2 you calculated its mean, so on and so forth. तो ये सारे means का average is going to be equal to population mean. So average of all x bars, that is average of all sample means. So x bar नहीं लिखता, average of all sample means is equal to population means. हमने क्लास में ये प्रूव भी किया था. एंड सेकंड वन, ये सारे ये जो सैंपल्स है उनका जो स्टैंडर्ड डेविएशन है, सो बेसिकली स्टैंडर्ड डेविएशन ऑफ द पॉपुलेशन इज इक्वल टू द स्टैंडर्ड डेविएशन डिवाइडेड बाय स्क्वायर रूट ऑफ n. याद है ये? यू गाइस रिमेंबर दिस? रेज दैट स्क्वायर रूट ऑफ n वाला कंसेप्ट. ओके, सो फर्स्ट वन holds for any population distribution assuming the sample size is large. That's right. Population should be normally distributed only and only if the sample size is smaller. So if the population is, if the sample size is large, then any population is fine. So this was a correct statement, but we are looking for a wrong statement. Okay, so this is not the answer. Okay, अब जो मैंने बोला था वो था basically standard deviation of the sample mean is equal to standard deviation of the population divided by square root of n. या ये जो अभी मैंने बोला था कि ये जो सारे sample means है, first sample का mean, second sample का mean, third sample का mean, dot dot dot, ये सारे sample means का average is equal to population mean, which is denoted like this. And ये सारे standard sample means का standard deviation is equal to population standard deviation divided by square root of n. तो अगर मैं इसको square करता हूँ तो it becomes sigma square and then its square root will go. So basically this becomes the variance, that's what they mentioned, the variance is equal to sigma square upon n, where sigma square is the population variance and n is sample size. So when that was correct, although the formula was like average of all x bar is equal to population average and standard deviation of x bar is equal to sigma population standard deviation upon square root of n. इसको square किया तो हो जाएगा variance and then square root will go. So that is sigma square upon n. So this was also a right statement. So two right statements. So this was the wrong statement. Let's look at what was wrong with the C, and hence C was the answer. Population states that population for a population with mean called as mu, this is general mu with variance sigma square. The sampling distribution of the sample means for any sample size will be approximately normally distributed. This is true if either of the two conditions gets true, which they have not mentioned. Either the population should be normally distributed or the sample size should be 30 or more than 30. तो बाकी सब कुछ उन्होंने मेंशन राइट किया था यहाँ पे. पॉपुलेशन का कैरेक्टरिस्टिक्स इज एवरेज इज म्यू एंड वेरिएंस इज दिस. Sample size n should be either 30 or more than 30 and the population should be normally distributed. Then only this will be true. So यहाँ पे ये जो will be approximately normally distributed, this is true if, so actually तीन condition है, I mean मतलब तीन conclusion है. Conditions are two, population should be normally distributed and sample size n should be 30 or above 30. इसमें से एक भी कंडीशन ट्रू हुआ तो तीन चीज प्रूव होती है. नंबर 1, नंबर 2, अभी हमने ऑलरेडी बोला था कि एवरेज ऑफ ऑल दोज एक्स बार्स, एंड बाय द वे हर एक सैंपल का साइज विल बी सेम. सेम जो रीसैम्पलिंग में था, बूटस्ट्रैप में था, सेम यहाँ पे ऑल द सैंपल शुड हैव द सेम साइज is equal to the population average, which is denoted as mu, but you can write population average. Standard deviation of the sample means, that is x bar is called as sample mean, is equal to population standard deviation divided by square root of n, which was mentioned in option A. And third, the x bars are also normally distributed. X bar matlab sample means. So average of sample means is equal to population mean. Standard deviation of sample mean is equal to population standard deviation divided by square root of n, and the sample means are also normally distributed. उन्होंने third में यही बोला था, the sample means are going to be normally distributed, but they have not talked about these conditions. So that's the reason it is not true for any population. It should be either normally distributed or the sample size should be large. Let's go and let's see where it was. So this was the central limit theorem. Bold maybe, yes, obviously can't miss it. So simple random samples, size n, and sampling distribution will be normally, but यहाँ पे उन्होंने mention as the sample size becomes large, ये उन्होंने mention नहीं किया था as the sample size becomes large. तो third में उन्होंने ये samples or any sample size mention किया था, so that was a mistake in the option C. And the two conclusions are like over here. So variance is sigma square upon n, that is standard deviation is sigma upon square root of n. The mean of population is equal to the mean average of all x bar equal to population average, and it should be greater than or equal to 30. And it should be repeatedly drawn with the, again, the members which are being taken in the sample should be again going back to the population so that they would also have a chance to be included in the next samples. Fine. And then the sample means will be randomly like normally distributed. So जो third point जो मैंने बोला अभी यहाँ पे, this point, the sample means x bar is also going to be normally distributed. So this was the first point that I mentioned over here. Second point is the average is equal to the population average. Average of x bar equal to population average, and then standard deviation equal to sigma upon root n. So keep in mind the three things. Sorry, the first two things. Number one, x bar, x second. Number one, the conditions. The conditions for the central limit theorem are the population should be normally distributed or the sample size should be 30 or more than 30. At least one, yeah, both conditions will be also fine. Then samples which are being drawn should be of the same size. This is same to like resampling and bootstrapping, same. Samples which are being drawn should be of the same size. And every time when you take the sample, you replace it back in the population so that it could also have the chances of being, those members could also have the chances of being included in the next sample. And you have to maintain the same sample size. Number one, conclusion would be that the every sample का जो mean आप calculate करोगे, that is called as sample mean, x bar we call it like that. So उसका average is equal to population average. Like you take 30 samples, let's say you take 5,000 samples. So there are 5,000 x bars. So 5000 X bars का average of those 5000 X bar would be equal to population average. Number one, standard deviation of those X bars is equal to sigma of the population divided by square root of n. And third thing is that those 5000 X bars will also be normally distributed. I repeat, you have taken 5000 samples where each sample have the same sample size. Let's say 40. Okay, so each sample has a 40 sample size. While taking samples, you had taken those members and then again replace it back in the population. So now those 5000 samples के 5000 X bars इनका जो average है that will be very close to population average. नंबर 2, ये 5000 X bar अगर आपने सेकंड 7 जो डेटा फंक्शन है कैलकुलेटर का उसमें डाल के सिग्मा कैलकुलेट किया तो दैट विल बी वेरी क्लोज टू सिग्मा ऑफ द पॉपुलेशन डिवाइडेड बाय स्क्वायर रूट ऑफ n. And third, ये 5000 X bars, if you plot it on the graph, it will look like this, normally distributed with skewness 0 and kurtosis 3. Okay, and वो जो sigma upon square root of n है ना, जो मैंने बोला, that is sigma upon square root of 40, not 5000. कितने बार सैंपल किया वो इंपॉर्टेंट नहीं है, सैंपल साइज इंपॉर्टेंट है. What I will repeat is, एक बार वापस करता हूँ कि जो 5000 टाइम आपने x बार किया ना, x बार फर्स्ट टाइम, x बार 2 टाइम, डॉट 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 x बार 5000 टाइम्स, ये 5000 x बार का जो एवरेज है would be equal to population average. Standard deviation of this X bars would be equal to standard deviation of population divided by square root of 40, which is nothing but the sample size. Each X bar, each sample में कितने members थे? That is said 40. And then this all X bars will be normally distributed. And for all this, the conditions are either the population should be normally distributed or the sample size should be 30 or more than 30. जैसे हमने यहाँ लिया था, sample size was 40. So coming back to the question, this was right because sample size was large, so this was fine. And this was also fine. Sigma upon square root of n was for standard deviation. तो variance के लिए sigma का square, sigma square, and square root of n becomes n. So these two were right. This was wrong because any sample नहीं था, large sample or population should be normally distributed. And hence C was the answer because you're looking for least accurate. Is it clear, guys? Raise hand if you have any doubts. I know थोड़ा सा लंबा गया, but I wanted to explain the central limit theorem in more detail. क्या वंदना?
एक बार skewness और kurtosis का कुछ बोला, वो एक बार रिपीट करोगे
Skewness
प्लीज?
for normal distribution is 0 and kurtosis for normal distribution is 3. So for normal distribution, skewness is 0 and kurtosis is 3.
ठीक है, थैंक यू.
Any doubt, guys? Let me know. Clear, no? Raise hand if it is clear. Good. Okay.